Have you ever looked up at the night sky and wondered, with billions of stars blazing across the cosmos, why is space so dark? This is Olber's paradox, a question that has puzzled astronomers for centuries. If you lit a billion candles in a room, it would be blindingly bright, yet the universe with its countless stars remains mostly black. The answer lies in the vastness of space and the nature of light. The stars we see are just a tiny fraction of what exists, scattered like distant lighthouses across an immense ocean. Their light travels in straight lines, but space is so vast that most of it never reaches us. The darkness is a testament to the universe's immense size, a reminder of our smallness. Imagine standing in a dark forest at night with only a few scattered candles. Unless you're close to one, you see mostly darkness. Space is like that, but on a scale beyond comprehension. The stars are the candles, and we are just one observer. The darkness is the default state of our universe. Yet this darkness is not empty, it's filled with mysteries where planets are born and galaxies collide. The darkness is the canvas for the universe's story. The stars are the brilliant characters, but the darkness is the setting. Without darkness, light would have no meaning. It's the contrast that gives the cosmos its beauty and wonder. The night sky's darkness is not an absence, but a story of scale, distance, and time. It's a silent stage for all of creation, and it's what makes the universe so breathtaking. The main reason for the darkness is simple. Space is almost entirely empty. On Earth, our sky is blue because sunlight scatters off air molecules, lighting up the whole sky. In space, there's no air, just a vacuum. Light from a star travels in a straight line. Unless it enters your eye or camera, you can't see it. Imagine spraying paint in a tiny room. The air fills with color. But in a vast warehouse, the paint shoots straight, leaving most of the space untouched. Our sky is the small room. Space is the warehouse. The emptiness of space is nearly absolute. Between stars, there are just a few atoms per cubic centimeter. There's nothing for starlight to hit or reflect off. That's why even near the sun, space looks black. Astronauts see the sun as a brilliant disk, but the sky around it is deep black. The sun lights up planets and spacecraft, but the vacuum itself stays dark. Space is a perfect canvas, letting celestial bodies stand out in sharp contrast. The darkness isn't a flaw, it's the backdrop that makes the universe's wonders visible. The void of space is what allows us to see the stars at all. It's the emptiness that frames the light. Space photos often show a black sky, even though stars are everywhere. This isn't because the stars aren't there, it's a limitation of cameras. Cameras, like our eyes, can only focus on one brightness at a time. To capture a sunlit astronaut, the camera uses fast shutter speeds and small apertures, blocking out faint starlight. The stars are simply too dim to register in these settings. If you wanted to photograph the stars, you'd need a long exposure and no bright objects in the frame, but then anything nearby would be washed out. So the black sky in space photos is a photographic choice, not a sign of emptiness. The universe is still full of stars. The camera just can't show them all at once. Next time you see a black sky in a space photo, remember, the stars are still shining. It's all about what the camera chooses to reveal. The darkness is an artifact of how we capture light. On Earth, our atmosphere helps us see the stars in a unique way. The air makes stars twinkle, a phenomenon called atmospheric scintillation. This twinkling draws our eyes to the stars, making them stand out against the dark sky. In space, without an atmosphere, stars don't twinkle. They're steady points of light. While this gives telescopes a clearer view, it can make faint stars harder to spot with the naked eye. Our atmosphere also acts as a weak lens, subtly enhancing the star's appearance. When we stargaze, we're looking through 100 kilometers of air, adding depth and texture to the night sky. The same atmosphere that hides stars during the day helps reveal them at night. On Earth, we get a shimmering, lively show, a reminder of the thin bubble of air that protects us. It's a uniquely terrestrial perspective on the universe. The universe isn't infinitely old. It began with the Big Bang about 13.8 billion years ago. That means there's a limit to how far we can see. Only light that's had time to reach us since then is visible. There's a cosmic horizon. Beyond it, galaxies shine, but their light hasn't arrived yet. The night sky is a live broadcast with a 13.8 billion year delay. The universe is also expanding and accelerating. As galaxies move away, their light is stretched or redshifted into wavelengths we can't see. The most distant galaxy's light is shifted out of the visible spectrum, becoming invisible to our eyes. Even if the universe were infinite, expansion would keep the sky dark. The darkness is a relic of the Big Bang and the universe's ongoing evolution. It's not just about emptiness, it's about time, distance, and cosmic change. The darkness is the fossil record of the universe's history. It's the shadow of creation itself. Our eyes see only a tiny slice of the universe's light, the visible spectrum, but the cosmos is filled with invisible light, gamma rays, X-rays, ultraviolet, infrared, microwaves, and radio waves. If we could see in microwaves, the sky would glow with the cosmic microwave background, the afterglow of the Big Bang. In infrared, dark clouds would blaze with the heat of newborn stars. Telescopes like James Webb reveal these hidden wonders, peering through dust to witness starbirth. The universe isn't truly dark, we're just blind to most of its light. What we see as a black void is a uniquely human perspective. The cosmos is a symphony of energy, playing out on wavelengths we can't detect. The darkness is an illusion, hiding a universe more brilliant than we imagine. The real mystery isn't why space is dark, but how much light we're missing. Our senses limit our view, but technology lets us glimpse the hidden glow. The universe is alive with light just beyond our sight. The darkness is only skin deep. We've explored the vastness of space, the tricks of cameras, and the limits of our perception. The darkness is a story of scale, distance, and time, a canvas for cosmic creation. The stars light up space, but the universe is so immense that darkness prevails. What we see is just a fraction of the cosmic symphony. The darkness holds the echoes of the Big Bang and the secrets of dark matter and dark energy. Every time you look up, you're seeing into the past, light that's traveled for years, even millions of years, to reach you. The darkness is the oldest thing we can see, a gulf of time and space. Perhaps the true mystery isn't why the stars don't light up the dark, but what the dark itself truly is. The universe's greatest secrets may be hidden in the darkness. If you enjoyed this journey, don't forget to like, subscribe, and hit the bell for more cosmic wonders.